your problem, but I have to take the class actually. I also don't have any option, or I also have a hectic day today. So come back here. This is context session number 7. And okay. Okay, just tell me what we have done till now. Do you remember something? I'm giving you the time. Write it. What you have done till now in the ProbStat course. Mr. Sanjeev, I'm asking related to the probability and statistic course, not the vector spaces. That is in a different course, mathematics course. Correct. So we have done discrete random variable. We have done their probability density function, CDF, expectation variance. After that, we have started the special distribution. That is, first is we have done binomial distribution, then hypergeometric distribution, Poisson distribution. Okay. So that distributions we have done. Now we are just doing multinomial distribution. And if you just see this multinomial distribution and Chebyshev inequality, that is already uploaded in the slides. That part is already uploaded in the slides. Okay. So this is a multinomial distribution. We are extending the binomial distribution. Binomial distribution is what? Can you recall binomial distribution? There are only two possible outcomes, either success or failure. So that's why it is known as a binomial. Okay, binary, like binomial. Okay, there are two possible outcomes, either success or failure. But if we have multiple outputs, multiple possible outputs, we can't say it is either success or failure. This is a combination. So in the binomial distribution, we can say we can extension the binomial distribution, and we don't have the only either success or failure. We have the k different outputs basically. So example, we are taking, consider drawing a ball from an urn which has balls with k different colors. For example, some are blue, some are red, some are green, some are black, some are white. So at a time, either we are talking about the only blue and not blue, so that is binomial. But if we are talking about the different colors, so at a time it is not a binomial distribution. Okay. So we can label the color 1, color 2, color k, and P is the probability P1, P2, Pk, where Pj is greater than 0 and summation of Pj is equal to 1, because probability at sample space is 1, you know very well. Suppose that Pj is the probability of drawing a ball of color J. Okay, so we are not talking about that it is a blue color or not. We are saying it is a color blue, green, red. Okay, so different colors. So we are taking the color 1, color 2, color 3, color 4, like this one. Okay, draw n times independent draws with replacement. So we are doing n times the trial, and We are just finding that is the how many blue colors balls are coming, how many red color balls are coming. Okay, out of the n trials only. So binomial distribution, what we were doing, if you remember, how many blue balls are coming, like for success, other are failure. But here we are just finding the same thing. How many blue balls, how many red balls, how many green balls, how many black balls, and so on. Okay. So we are saying x is equal to x1, x2, xk, where xj is the number of times the color j appears. Hence, n is equal to summation of xj. So we can say x follows the multinomial distribution with parameters NP distribution, where P is equal to, we can say P is coming here in the form of P1, P2, P3, P4, P5, and so on. Okay. And N is the number of trials. And P1 is what? That is the probability of coming first color. P2, that is the probability of color 2, and so on. Okay. So X follows the multinomial distribution, and the probability density function is given by NC x1, x2, xk here. Okay. Now, if you remember the C which we are talking about, so NC1, if we are talking about, so it is n factorial upon 1 factorial into n minus 1 factorial. Here we are talking about the n C x1, x2, xk. So what we are saying here, n factorial upon x1 factorial, x2 factorial, x3 factorial up to xk factorial. X means the number of balls drawn. X is a random variable, independent draws and identical. Do you remember in the binomial distribution, the assumptions? Independent draws, okay? One has no effect on the another one. And with replacement means what? If we are taking a one ball, so we are not keeping with us. We are just keeping the bag. So another, when we just draw the another sample, another ball, then that particular ball may come another. Repetition is allowed. We are not reducing the sample space. That is with replacement. Got it? In hypergeometric distribution, do you remember? We are doing without replacement. Clear? So here we are just saying x1 plus x2 plus x3 plus and then xk. What is this? When we are adding these, can you tell me? X1 is the number of balls of color 1. X2 is the number of ball color 2, and so on. How many balls we have drawn? Total n. So that's why these are coming total n here. Okay. So this is NC x1, x2, xk. And this is P1 to the power x1 multiplied by P2 to the power x2 and P3 x power x3 and so on. So this is the probability density function. After that, we can find out any type of probability which is required. Okay. Come to the example. Suppose that in three-way election of a large country, candidate A received 20% of the votes, candidate B received 30% of the votes, and candidate C received 50% of the votes. Okay. Hypergeometric and multinomial are very much different. Okay. Multinomial is the extension of the binomial distribution. In the binomial distribution, if you remember, just NCX p to the power x 1 minus p to the power n minus x, where x is equal to what? 0, 1, 2 up to n. That is the binomial distribution. Instead of here we are using NC x1, x2, xk, because we are not taking only the one x here. Here it is success and failure. Here there are no success, no failure. There are different probabilities. So that's why p1 to the power x1, p to the power x2, and so on. pk to the power xk. Got it? So they are different. So here what we are saying, there are three candidates, total three candidates. Now, if 6 voters are selected randomly, what is the probability that there will be exactly one supporter for candidate A, two supporters for candidate B, and the 3 supporters for candidate C in the sample? So now, how many times we draw? That is, we are drawing 6 times. So n is equal to 6 here. 6 times we are taking the supporters. Got it? So now we can say x1, x2, x3 denotes the number of votes for candidate A, candidate B, and candidate C respectively. How many votes we are talking about? N is equal to 6 here. And probability for first candidate is what? 0.2. Second candidate is 0.3. And P3 is 0.5. Clear? Now there's asking about a one candidate. X1 is equal to 1 for A, supporter A. X2 is equal to 2. And x3 is equal to 3. Clear? So now we are just using here the same formula, that n factorial, that is 6 factorial upon x1 factorial, x2 factorial, and x3 factorial. Okay, 0.2 to the power x1, that is 1, 0.3 to the power x2, that is 2, and 0.45 to the power 3. Got it? So 0.2 to the power this, 0.3 to the power this, 0.5 to the power 3, and answer is 0.135. So here what we are doing, we are just extending the binomial distribution from either success or failure to the so many type of possible outcomes. That is the concept which we are using here. Is it clear to all of you? Not clear? One is a value of x1. Mr. Ranjit, what is the power of 0.3? 0.3 is the power 2. X2 is equal to 2. X3 is equal to 3. Okay. So that is the extension of binomial distribution only. That is why it is known as a multinomial. Binomial or multinomial. Got it? Now come to the next theorem, that is the Chebyshev theorem. Basically, if we don't know the formula, is this? Yes. 20% chance means 0.2 probability. Okay, Mr. Sanjeev? So, Chebyshev theorem says, if we don't know the, thank you. If we don't know the distribution, so at least some idea we have to take from the, it is given in the question 1, 2, 3, x1 is equal to 1, x2 is equal to 2, and x3 is equal to 3. It is given in the question. Okay. So what we are saying here, in this case, what we are trying to say, that if we don't know the distribution, so at least some idea of the probability. Okay, but it is given with, see the question, how will be exactly one supporter for candidate A, two supporter for candidate B, and three supporter for candidate C? It is given in the question, Miss. Okay. So what we are doing, we don't know the distribution, only we know the mean and standard deviation. So X be a random variable having mean, mu and standard deviation, but we don't know that it follows the binomial distribution, it follows the Poisson distribution, multinomial distribution. We don't know exactly. Okay, by the question it is not given information that okay, it is follows this distribution. So what we can say, then for any positive number k, the probability of getting a value x which deviates from mu to at least k sigma is at most 1 by k square. For mathematically, we can write it probability mod x minus mod of, oh, 1 second. Probability of mod of x minus mu is greater than k sigma is less than equal to 1 by k square. So at least we are getting the upper bound. Okay, we are getting the upper bound of that probability. We don't know the distribution. If we know the distribution, we can calculate the exact value. But here we don't know the exact value because we don't know the probability distribution. So what we can say, by Chebyshev theorem, we can identify what is the upper bound. If lower bound, you know the probability is 0, but it is upper bound is 1, but we can find out at least some idea of the upper bound of that particular probability, that is 1 upon k square, and k is coming from this, which is k sigma here. Okay, I will show you here that it is mean mu here. No, so we can just go like these are 3 parts we are dividing this one. So it is mu minus k sigma, mu plus k sigma. Okay. So we are taking the reason R1, R2 and R3. So the probability of R1 union R2, probability of R1 union R3 is, we can say, less than equal to 1 by k square. Okay. Where this area we can find out by the mu minus k sigma and mu plus k sigma. This is the Chebyshev theorem basically. Okay. So we are just taking the remarks here. The event, because here we are just talking about the greater than k sigma. So we can also say another form, that is the probability of the R2 reason only, because we are finding R1 union R3. What is the probability of R2 only? So that is greater than equal to the 1 minus 1 upon k square, because total probability is 1, you know. So R1 union R3 is less than equal to 1 by k square. So probability of R2 reason is what? It is greater than equal to 1 minus 1 upon k square. Okay. So we can also find out the all 3 reasons, the probability of all 3 reasons specifically. Just give me 1 second. K is some value specifically, either it is 1, 2, 3, any integer for any positive value, positive integer basically. And if we can just extending it, so it is coming here. If we can say k sigma is equal to epsilon, so we can say it is epsilon, and here it will become sigma square upon epsilon square. So that is become variance of x upon epsilon square. This is the another way to write it. This is the same expression, only the way of representation is changed. Just a minute, it's not moving. I don't know why it is not moving. Just give me 1 minute. Just give me 1 second actually. But my tab is hanged, so just wait. Are you able to see the slides? Are the slides visible? Okay. So here we are just discussing about the problem of the Chebyshev inequality. So in 1 out of 6 cases, material are bulletproof, vessel fail to meet puncture standard. If 405 specimens are tested, what does Chebyshev theorem tells about the probability of getting at most 30 or at least 105 cases that do not meet puncture standard? Okay. So this is the question by the Chebyshev theorem that we have just tell about the probability of getting these two conditions. So X be the number of cases do not meet the puncture standards. X is a random variable having the binomial distribution with parameter n is equal to 405 and p is equal to 1 by 6. Okay. Why we are taking this question? Because we can compare the Chebyshev theorem with the actual values also. That's why we are just taking the question of the binomial distribution. Okay. Now they're saying find out the probability X is less than equal to 30 and X is greater than equal to 105. Okay. So here it is n is 105 and p is equal to 1 by 6. So we can find out NP, that is mu 135 by 2 here. Okay. Sigma is equal to square root of NPQ. So it is 15 by 2. That is the standard deviation. Okay. Because we are just using the Chebyshev inequality. So we required the mu and sigma. Now, which we are saying x is greater than equal to 105. So what we will say? 105. So we can just taking minus 135 by 2. Why we are taking 135 by 2? That is mu here. 135 by 2. So x minus mu. So x minus mu is greater than equal to 105 minus 1 by 35. 135 by 2 here. So that is 75 by 2 here. Okay. So when we are just taking the probability of both sides like this one. Okay. Probability of this. So now, similarly, we can find out x is less than equal to 30. So we are taking the mu, x minus mu, x minus mu. So x minus mu is what? 30 minus 135 by 2 here. Okay. Both side we are taking. So now this is coming here minus 75 by 2. So if we are seeing the question, if you just go back, so we are seeing here x is greater than equal to 75 by 2. And here we are reaching x is less than equal to 75 by 2. Okay. And this is what? It is not x basically. It is x minus mu. X minus mu. Okay. So what we have to find out? This is what? K sigma. Okay. We know the sigma. So from this value, we can also identify the say K. Okay. So what we are doing here? Now x is less than equal to 30 or x is greater than 105. We can say x minus 135 is less than equal to minus 75 by 2. Or, so this is the R1 and this is the R3 basically. Okay. So x minus mu greater than equal to 75 by 2. RHS is negative. Yes, it is minus 75 by 2. This is positive 75 by 2. This is negative 75 by 2. So as we are defining the line, this is mu. So it is minus 75 by 2 and this is 75 by 2. Okay, so this is mu minus k sigma is equal to minus 75 by 2. And we can say mu plus k sigma is equal to 75 by 2. Okay. So here we can say we know the sigma. So it will become minus 5 sigma and plus 5 sigma here. So we know the sigma here. So from that we can find out k is equal to 5. Okay. And by the Chebyshev inequality, these two values, that is R1, this is R3, and that should be greater than equal to 5 sigma because we have taken the modulus, and that is by 1 upon 20k square here. So 1 upon k square, that is 0.05. So the upper bound of this probability, this reason is 0.04. Okay. And the lower bound of the R2 reason is what? 1 minus 0.04. Is it clear to all of you? So this is just a simple Chebyshev inequality. And here we do know the binomial distribution. So we can also calculate the exact value of this probability. But here we are just talking about from the Chebyshev inequality. And when you can compare it, it is very small error here. Okay. Now we are just doing the summary of the some important distribution which we have already done. So first we have done the binomial distribution, then geometric distribution, hypergeometric distribution, and Poisson distribution. How k is equal to 5? Okay, just tell me. What is the sigma? Sigma is 15 by 2. Now you can calculate. I think you forgot about the sigma. So K mu plus K sigma is equal to 75 by 2. Mu is equal to what? 135 by 2 plus, and here no, sorry. In this one, K sigma is 75 by 2. So it is K into sigma, it is into 15 by 2 is equal to 75 by 2. So from that, K is equal to 5. Thank you. Okay. So we have done here the four distribution: binomial, geometric, hypergeometric, Poisson, and we extending the binomial distribution as a multinomial distribution and Chebyshev inequality. That is two parts we have done. So this is the probability distribution. Density function is given. Here it is the mean, as you were saying here. Okay, just a minute. Which slide? You can see you can see these things from the slides. I will upload the slides also. Okay. So here, this is the mean, this is the variance, this is the movement generating function of a binomial distribution, geometric distribution. So this is the density function. 1 by P is the mean, variance, and then movement generating function. Similarly, for the hypergeometric distribution, mean, variance, and we are not calculated. Poisson distribution, that this is the density function, mean, variance, and movement generating function. And then we have done today multinomial distribution and the Chebyshev inequality. Okay, that part we have done in the last chapter, chapter 4. Now come to the chapter 5, that is the continuous random variable. So as I told you when I started the random variable, there are two type of random variable, discrete and continuous. So we have done the discrete random variable, their probability density function, their CDF, cumulative distribution function, expectation, variance, and so on. Similarly, we can go for the continuous random variable, that is chapter 5. So in the continuous random variable, what is it? You know very well. If they are not discrete, so they are continuous, simple. So if we have just come across a random variable that takes all values lying in a centered interval of x-axis. For example, we are talking about the length. So length is maybe 1.01 centimeter, 1.001 centimeter, and so on. So any value between 1 and 2 they can take. Okay, so that is not the case. Then we are taking only 1 centimeter or 2 centimeter. It may take any value. Similarly, the mass, if we are talking about, if we are saying talking about the density of a okay, so that random variable is known as the continuous random variable. So that is, for example, life length of x of bulb is continuous random variable. So life length means what? The time. We are talking about the time. So that is also all non-negative real values they can take as a life length. The time between two consecutive arrivals in a queuing system is a random variable that can take all non-negative value. Okay, first arrival and the second arrival. So that part of question, if you remember, we have done in the Poisson distribution. So first arrival, second arrival, they may take 5 minutes, they may take 10 minutes, 20 seconds, and so on. Okay, so any non-negative value they can take. So that's why they are continuous random variable. The profit made by firm during one financial year is also a continuous random variable. Okay, profit made by firm, it may be negative value, it may be positive value. If it is negative, so we are talking about the loss. If it is a positive value, so we are talking about the profit. Okay. So that is the continuous random variable. Now it is clear in all such cases, probability that the random variable takes any one particular value is meaningless, because one particular value, there is no probability that we are talking about, just like in a discrete case. So it is the probability at one particular value is always be zero in the continuous case. So we only ask for the probability that a random variable takes value in an interval. Okay. So in the discrete case, we are talking about the probability at one point, where in the continuous case, we are talking about the probability in an interval, not at one point. At one point, continuous random variable, the value is, probability is zero here. That is the important difference between these two here. For example, when you buy a bulb, you ask the question, what are the chances that it will work for at least 500 hours? You are not saying that you can find out the probability when x is less than equal, greater than equal to 500. You are not saying exactly 500. Okay, probability at x is equal to 500, that is zero. We are not able to find out this one. So at least 500, at most 500, and so on. Like, okay, so it is should be in an interval basically. So x is called a continuous random variable if it range is an interval of real numbers and the probability that it assumes any specific value is zero. At a specific one value, it is zero here. Probability at one point, it is zero in the continuous case. So the density function, probability density function, it is in this one, if you remember, the probability density function in the discrete case, that is, we are saying, right, fx is equal to probability when x is equal to x. But in the discrete case, okay, but in the continuous case, it is just zero. So what we are saying, we are defining the interval. So x takes value in an interval a, b, and answer defining a probability density function in that in terms of AB. So we are just taking here the three values. Probability when A is less than x is less than equal to B is interval integration from A to B fx dx. Okay. So that is the concept we are using as the C part. So instead of taking a one point, we are just taking here in the range of A to B basically. Okay. Now you know the probability when we're talking about the probability. So it is all value for all values of x. It should be greater than equal to 0, and integration in the complete interval, it should be equal to 1. So integration from minus infinity to infinity fx dx should be equal to 1. So these are the two important properties of the probability density function. That is the two axioms of the probability, which you may have done in the discrete case also. Okay. So we are extending that part which we have done in the discrete case in the continuous part. Okay, just extension only. So what we are changing here, the two things we have changed. Have you noticed? What is the distinct difference between the discrete case and the continuous case? How you can distinguish between these two cases till now? Yes, I am waiting for your reply. Probability at one point, it is equal to 0 in the continuous case, where the probability at x is equal to 1 point is exists in the discrete case. One thing. Second thing is the probability density function. In that one, we are using the integration. In the continuous case, in the discrete case, we have taken the summation. So if you remember, we are using the summation for all fx dx is equal to 1 in the discrete case. So we are taking the summation because we have the discrete values. But here we don't have the discrete values, so we have to take the integration. So in all the formulas which we have done in the discrete case, the summation we used, that is replaced by the integration. That is the only one difference in the discrete case and the continuous case. All formulas, in the all formulas, wherever we are using the summation, we are replacing it with the integration. In the continuous case, all formulas are same. All concepts are same. We are not changing the concept actually. What we have already done. Got it? So that's why the summation of all fx dx is equal to 1. Here it is integration minus infinite to infinite fx is equal to 1. Here integration is 1 here. Okay. So this is the case here when we are talking about the continuous function. We are just talking about the continuous. So it is a continuous curve. Okay. So this probability is defined from the range A to B. So the area, the probability, what it defines, that in that curve, when we are just defining the density curve, and this is a continuous curve because it is a continuous function. So we are just making our ranges A to B, and this area is denoted by the probability when A is less than X is less than equal to B. In this range, what is the area of this curve is denoted by the probability. That is the geometrical meaning of this probability in the continuous case. Okay. And which is equal to the integration from A to B fx dx. Now come to the remark here. First remark, probability when x is equal to A is what? 0. So probability when x is between A to A. So we are taking integration A to A fx dx and it is equal to 0. Got it? But when we are talking about the probability when A is less than equal to X is less than equal to B, so we are including equal sign or not. Hardly matter for me. Why? At X is equal to A, the probability is 0. So if X is equal to A is included or not included in the probability, it's hardly matter. Okay, that will not change us. Similarly, if we are not including equality sign and if we are not included the equal sign here. All type of probability are same in the continuous case. In the discrete case, they have the different values. Okay. In the different case, they are just different values here in the discrete case. But in the continuous case, it is same. So unlike discrete cases, it is immaterial whether we include or exclude one or both the endpoints. Okay. So here, this is the third difference in the discrete and continuous, that in the discrete case, if we include or exclude one point, always matter. But in the continuous case, if we include or exclude the endpoints, it doesn't matter. To calculate the probability value always coming same. After density function, we are talking about the CDF. What is the formula for the CDF? In the discrete case, cumulative distribution function of a x. In a discrete case, can you remember? Can you recall? Tell me. I'm waiting for your reply, please. I'm not getting any reply on the chat box. So I will repeat it. It is denoted by capital Fx, and that is what probability when x is up to that point. Correct. Correct. Okay. So here Fx is equal to probability at that point. The same answer we are using in the discontinuous case. No change at all. Okay. So probability when x is less than equal to x. So probability from minus infinity to x. And here, instead of summation, because here in the discrete case, we are taking the summation up to the point x of the density function. है ना? Same here, minus infinity to x, we are taking the integration of ft dt. So instead of summation, we are using here integration. Definition is same. Fx is equal to probability when x is less than equal to x here. Okay. So we are denoting it by again capital Fx, and it is denoted by the cumulative distribution function of x. So no change in the conceptual definition, only because it is a discrete case. So we are using summation up to that point of all the probabilities. Or if it is discontinuous case, then we are using here integration. Clear? Are you getting my point? So here, up from minus infinity to that point, we are just taking all the values, all the areas. So that's why it is capital Fx. Okay. So capital Fx is the area under Ft. Ft is what? Density function from minus infinity to that point x here. The complete area we are talking about. Integration minus infinity to x ft dt here. Now properties of CDF, we are using the same concept. 0 is less than equal to Fx is less than equal to 1. If x1 is less than x2, so f of x1 is also less than equal to f of x2. That is, it is a non-decreasing function of x. In the discrete case, if you remember, it is a step function. But here, it is not a step function, it is a continuous function. And it is non-decreasing up to the 1 here. It is 1 and it is started with the 0. Like, okay, it may be any curve, but it between 0 and 1 only. So f of minus infinity, we are talking about it is 0, and f of plus infinity, it is equal to 1 here. So it is go and up to 1, and it will start from the minus infinity, 0. Okay. And we know that probability when x is greater than small x, it is 1 minus fx. That is the same concept as we have done in the discrete case. Fourth is what? How we can calculate the PDF from the CDF, the probability density function from the CDF. That is to differentiate it, because we are finding the CDF by integrating them. So what we are doing? We are calculating the PDF by using the differentiation of it. Find out the Fx. So thus we can get density function Fx by differentiating the distribution function, cumulative distribution function Fx. Okay, we are differentiating the integration, so that's why we are getting the same answer. Probability when A is less than X is less than B is what? FB minus FA. Now come to the question. Exercise 5.2 in your textbook. If the probability density of a random variable X is given by kx square in the range of 0 to 1 of X, otherwise it is 0. So this is the density function. Now how we can say it is a density function? Because it satisfies the two properties. What are the two properties? One is fx should be greater than equal to 0 for all values of x. So here for all values of x means it is between 0 and 1 or 0 elsewhere. Okay. The second is what? Integration minus infinite to infinite fx dx. It should be equal to 1. Okay. So when we are just using this, so what we are doing, integration minus infinite to infinite fx dx is equal to 1. So when we are using this concept, then we can calculate the value of k also. So find the value of k and probability that the random variable takes on a value between 1/4 and 3/4 and greater than 2/3. How you can do it? So we are just calculating minus infinite to 0. What is fx dx? It is 0. Plus 0 to 1, it is kx square dx. Plus 1 to infinity, it is again 0 dx. And this all integration is equal to 1. So this is 0, this is 0. So we are getting here 0 to 1 kx square dx is equal to 1. Now you can integrate it. It's a very simple. That is k, it's outside. It is a simple constant. And x squared integration is what? X cubed by 3. And the limit is 0 to 1. Okay. Which is equal to 1. Now we can find 1/3 minus 0 is equal to 1. So here it is k/3 is equal to 1. So k is equal to 3. Correct, Mr. Sanjeev. So k is equal to 3. Now you find out all the values. Now the second part is what? Calculate probability when x is between 1/4 to 3/4. How you can do it? That is integration from 1/4 to 3/4 fx dx. Please repeat. You can see integration from minus infinity to infinity. Now it's clear. So it is 1/4 to 3/4. K is what? 3. So it is 3x square dx. This is a property of the PDF only. This integration should be equal to 1. When we define the PDF of the continuous random variable, this is the property. Otherwise, it is not a PDF. Every random variable comes into this rule. Okay. So this is what 3 x cubed by 3, and the limit is we are taking here 3/4 to 1/4. So this 3 is cancelled out. So x cubed 3/4 1/4. When we are putting the values, we are getting here 13/32. Can you calculate this one? Probability when x is greater than 2 by 3. Probability when x is greater than 2 by 3. So we can just use 1 minus probability when x is less than equal to 2 by 3. It is 1 minus integration from 0 to 2 by 3, 3x square dx. Another method is what? I will write it here. Probability when x is greater than 2 by 3. So you can write it here. 2 by 3 to only 1. Why it is only 1? Can anyone can define why we are taking only 1? 3x square dx. Why we are taking up to 1 only, the last limit? No, it is not because of p max is 1. It is because x range is 0 to 1. X is not moving before beyond 1. If it is 1 beyond 1, so the value of density function is 0. Okay, Mr. Sanjeev? This one we are taking because probability at max is 1. That's why it is coming 1. Okay. So here x is varying from 0 to 1. If we are just saying x is less than 1, that's why we are taking here 3x square up to 1 only. Otherwise, it is become 0. Clear? So now you can do by any method. Answer is coming. Same simple integration. So 2 by 3 to 1, 3x square dx. And when we integrate it, so it is coming 19 by 27. Why you're not getting? What is the problem? Just probability, way of calculating probability in the continuous case. In the discrete case, we are adding it. In the continuous case, we are integrating it in the same range. Okay. So here we are saying here x greater than 2 by 3. So 2 by 3 to 1 because x is 1. Now we can also say express in like this one. It is 2 by 3 to infinite fx dx. Okay. Now we can divide 2 by 3 to 1. It is 3x square dx plus 1 to infinity. What is this value? Fx dx is 0. So that is 0 actually. So that's why we are taking here. Oh, that's why it is coming here only this value. Now it's okay. Not able, confusing. Why it is confusing? X is greater than 2 by 3. So the value x is greater than 2 by 3, we have to calculate the all probabilities. So 2 by 3 to infinity. X to the power 4 by 4. Why it is coming x to the power 4 by 4? It is not x cube. Mr. Sanjay, it is x square. 3 multiplied by x square. So x cube by 3. And 3 is cancelled out. So only x cube is remaining. That is changed actually. Sometimes it is due to the addition problem. It is maybe changed. So I'm just leaving it here. Just taking a break. 5 minutes break. You can just try to check out. It is directly given in the question. Please read the question carefully. What is given in the question? If you're reading the question, then it is very easy actually. Which type of probability when reading a question? You can see it is given. Find the probability that a random variable takes the value 1/4 to 3/4 greater than 2/3. Everything is given in the question, Mr. Sanjeev. So there is not a matter of worry. Read the question carefully, then only you can answer. Now, I am doing the same. I am trying to understand your question and try to give the answer. Firstly, I am also reading your question, try to understand, and then I am replying you. Same here you have to do. Read the question carefully, then no confusion, no worry. Okay. Important thing is just read the question carefully so that you can define, okay, what is given in the question, what is asked in the question. Okay. So what is given in the question? That x is a continuous random variable. Its density function is given in this range 0 to 1. And we have to find out the value of k by using the first concept of the probability distribution. And thus, by direct formula, you can calculate the probability. Any type of probability you can calculate. Okay. It's clear, Mr. Sanjeev? So please read the question carefully. Everything is given in the question. Only you have to understand it. So I'm just taking a break. Yes, if ranges is given, that it will fall under this type. Every time the range is given. If range is not given, Mr. Mahendra, please see the calculation which we have done. Direct formula based. K is coming 3. Okay. So I'm just taking a break. 5 minutes break and then we will come back. Welcome you back after the break, short break. Any query till now? You just try other questions so that you can find out the things. In a one question, it's very difficult to understand, definitely. But when you just do some more questions, then it will helpful for you. Now come to the next question. With the reference of the preceding exercise, find the corresponding CDF and use it to determine the probabilities of a random variable during this distribution. Same question. We have to find out the probability greater than 0.8 and between 0.2 to 0.4. It is given in the question. Okay. So firstly, we have to find out the CDF of the same question and greater the probability between greater than 0.8 and between 0.2 to 0.4. The distribution function is what? This is the formula. Okay. Now we are taking the three ranges when x is less than 0. X is between 0 and 1 and x is greater than 1. Three case ranges we have to take for capital Fx. So when x is less than equal to 0, so ft is equal to 0 on those cases. So fx is equal to 0. Got it? When x is between 0 to 1, our ft, the density function, is provided. So we are just taking here ft is equal to 3t square between 0 to x. So we are just integrating it. It is coming x cube. Okay, minus infinity to x, 3t square dt, 0 to x, 3t square dt is equal to x cube. And the third range is what? When x is greater than equal to 1. So ft is equal to 0 in this range, ft is equal to 3t square in this range, and ft is equal to 0 again in the t is greater than 1. So we have to take all the three ranges. For example, I am doing here. So we are just taking here fx is equal to minus infinity to x ft dt. We divide it into the three range. First is minus infinity to 0. So it is 0 dt, 0 to 1, 3t square dt plus 1 to x, because x is greater than equal to 1. It is 0 dt. So this is 0, this is 0, 3t square dt is equal to 1 here. So that's why it is 1. So we are just finding the answer. CDF is what? In the complete range. When x is less than 0, it is 0. 0, 7, it is x cube. And when x is greater than equal to 1, it is 1. So if we are talking about f of 20, can you find out f of 20? It is what? 1. Because 20 is greater than 1. So the CDF is this. Okay. But the density function is what? Is 0. This is the function, capital Fx. Okay. Because this is the curve of x cube. And after that, it is 1, it is 1. And before it, it is 0. Now, are you able to get it? Am I audible? Are the slides visible? Thank you, thank you. Because after the break, no one is responding me. Now you can find out the another part. Probability when x is greater than 0.8, greater than 0.8. So it is 1 minus less than 0.8. Okay, that is what? F of 0.8. 0.8 is coming here between 0 and 1. So it is the answer is x cube. So 0.8 cube. So 1 minus 0.8 cube is 0.4888. By using the CDF and by using the PDF, how you can do it? We have already done 0.8213 x square dx. So same thing, x cube 1 to 0.8. So it is 1 minus 0.8 whole cube. Finally, we are reaching to the same expression by using the CDF or by using the PDF. Probability density function or cumulative distribution function. Next one is what? 0.2 to 0.4. So by CDF, how we can do it? Probability when x is less than equal to 0.4 minus probability when x is less than 0.2. So f of 0.4 minus f of 0.2. What is f of 0.4? 0.42 whole cube. And 0.2 to the power whole cube, and answer is 0.056. Is it clear to all of you? Mr. Sanjeev, Mr. Mahinder? Mr. Sanjay, Mr. Rahul, Mr. Dhamotaran, Mr. Rohit. It's not clear. Thank you, Mr. Abhishek. What is the problem? Any doubt? You can write me the doubt. Okay. That's why I'm going just slow. You can see now I'm just giving you the time. Fx is equal to 0 elsewhere. So we are taking 0 for x, fx. Fx is equal to 0 elsewhere. We are not taking. Capital Fx is not equal to 0 elsewhere. Small fx is equal to 0 elsewhere. Okay? But capital Fx is 0 up to 0 point and 1 after the 1 point. Okay, there is a difference between the small fx and capital Fx. Miss Rakhi, actually it is not allowed to take the extra class on weekday. It's not possible at all. I can understand your problem. That's why you can see the recording as well. Slides are also available. But I have to complete the syllabus as well as because I have to take some leaves actually. And I want to, the question itself is the same. This is the question. Find out the CDF and find out the probability of these 2 points. If you're seeing the handout now, so we are just behind or according to the handout. Because my pace is very slow actually according to the handout. That's clear? Now, another question. Let us that the phase error in the tracking device have probability density function is this. Cos x from 0 to pi by 2. X is between 0 to pi by 2. Okay, 0 elsewhere. Now, find the probability that the phase error is between 0 to pi by 4 greater than pi by 3. How you can find out? So it is what? That probability when it is 0 less than x is less than pi by 4. So what you will do? You are just taking the integration from x is equal to 0 to pi by 4, and in the pi by 4 the fx is equal to cos x dx. Okay, solve it. Similarly, probability when greater than x is greater than pi by 3. So what we will do? It is up to pi by 2 only. So the integration pi by 3 to pi by 2, and it is cos x dx. Solve it and you can find out the answer. This is just a formula based question. Okay. Similarly, the another question, please try to your own. You can do it, I believe. Just integration. So I am giving you some more questions as you are saying now that you want some questions for the practice point of view. So these are the practice point of view questions. Please do it your own. Now next part is what? Expectation. So you have done in the expectation in the discrete case. Here we are doing the same expectation. Only the summation sign will change to the integration. This is a simple question. I am leaving on you. You have to do it your own for practice purpose. Okay. So expectation of any function hx. Phase error 1. Okay. Just give me 1 minute. Is it, Mr. Rahul? Here, probability density function is given. Find out that this power supply will be inadequate in a given day. So they are given it has a daily capacity of 12 million. So it is more demand than it is not inadequate. It is not adequate. More than 12. You have to find out the probability. And here the range of x is greater than 0 for up to the infinity. Okay. Read the question, you can do it. So expected value of any function hx can be written as integration from minus infinity to infinity. Hx is multiplied by probability density function. Provided that right hand side integration converges absolutely. Matlab it should exist. At least you can find out the integration value. So if we are saying x is a continuous random variable, so mu is what? Expected value of x. We are using the same formula, x multiplied by fx dx. No change at all. In the discrete case, it is what? Summation x fx. For all x, summation. है ना? Here what we are changing? We are changing is integration. Integration minus infinity to infinity. X fx dx. Okay. Similarly, I don't know why it is. So I will just do it here. Sigma square, that is the variance. How you can calculate the variance? X minus mu whole square fx dx. That is what? Integration minus infinite to infinite. x minus mu whole square into fx into dx. Okay, same formula. So if you remember, in the discrete case, what we are doing? We are using summation x minus mu whole square fx for all x. Here we are doing integration. Concept is same, only because it is a continuous random variable, that's why we are changing it. Computational formula, you know very well. Expected value of x square minus mu square. And when we are taking the positive square root of the variance, that is known as the standard deviation. Now come to the question, same question. Find its mean and variance. We have done the same question. We have find out its CDF. We have find out different type of probabilities. Now we are just what? We are doing the its mean and variance. How we can do it? Sorry, expected value of x is what? Integration minus infinity to infinity x into fx dx. This is the basic formula. Now, minus infinity to 0. It is x multiplied by fx is 0, 0 dx. 0 to 1, x, it is 3x square into dx. Plus 1 to infinity, because we have to take minus infinity to infinity. So 3 parts we have to done. So x into 0 into dx. So this is 0, this is 0. Only remaining is this. So that is what? 0 to 1, 3x cube dx. X to the power 4 by 3 multiplied by 4, 0 to 1. So what is coming? 1 by 12. Oh, sorry. I have done mistake. It is not 3. It is 3 here. Sorry. So this will become 3 by 4. Are you getting my point here? Thank you. Now how to calculate the expected variance? Variance is what? Expected value of x square. We have to calculate the expected value of x square. Mr. Mahendra, this is the question. 3x square. You just integrate it and you will get the answer 3 by 4. Integration is I have already done. Three x square integration minus infinity to infinity x square multiplied by fx dx. 3 parts. I'm just leaving the 2 parts because they are coming 0. We have done. So now it is minus, or we have taken 0 to 1 only 3, or you can start with x square multiplied by 3x square dx. So it is 3 x to the power 4. Integration 0 to 1 x to the power 4 dx. So that is equal to 3 x to the power 5 by 5. 0 to 1. So it is coming here 3 by 5. So variance of x is what? The formula is expected value of x square minus expected value of x whole square. Expected value of x square is 3 by 5 minus expected value of x is 3 by 4 whole square. Solve it, you will get the answer. It is 3 by 5 minus 9 by 60. It is given on the slides also, but I am just trying to do it on by hand. I am showing the calculation also so that you can understand it better. Correct? Standard deviation is what? Square root of variance. So root 3 by 80. 0.194. That's clear to all of you? Next question. X be the total medical expenses incurred by particular individual during a given year. Although X is a discrete random variable, suppose its distribution is quite well approximated by the continuous with PDF. Okay. Variance is 0.0375. Correct. So here density function is given by this. When X is greater than equal to 0, what is the value of K? What is the expected value of X and standard deviation? Mean and standard deviation. You can calculate it. It's very simple. And then this individual is covered an insurance plan till 500 deductible provision. Then the plan will pay 80% of any additional expenses exceeding $500. Okay. So we have to find out the Y and its expected value. Please try it on your own. This is the answer. Okay. So as you are saying, just leave early. So I am leaving here because next is the new distribution, normal distribution. Okay. That is, we have done mean, variance, PDF and CDF of the continuous random variable. Okay. So we have done the continuous random variable, its PDF, its CDF, and then we have done mean, we have done variance, and we have done different type of probabilities of a continuous random variable. Up to EC2, yes. Up to this chapter, chapter 5, normal distribution, chapter 5, continuous random variable. I will try, Mr. Rahul. I believe that you can do it. If you are just attending the classes, do the practice, you will get it. I also giving you the tips that please read the question carefully. What is given? What is... Sure, sure. I know you can do it your best, and you will be passed. Okay, Mr. Rohit. Actually, these are not a very notes, class note, just a calculation I am showing, which is already on the slides. I already told in the last class. Nothing is special in the notes. Just for understanding purpose, we are writing it. Otherwise, everything is given in the slides. That's why I'm not uploading it. So my tip is what? That please read the question carefully. What is given? What is asked? What is random variable? What it is distribution? What are the parameters? And then calculate whatever it is asked. It is already uploaded on the team. Mr. Manoj, It is already uploaded on the team. All the presentations are available. No. You can't say like this one. I'm uploading it and it is showing to me also. I will upload today's class as well as some part of the normal distribution today. Okay. You will find out in the course material. Please check all the recordings as well as all the presentations already available on the team. Okay. Okay. Enjoy your evening. Tomorrow at 8:20, we will meet again. Thank you. Thank you so much. So in the next class, we will start the normal distribution. I will try to give you the easy questions and I am giving you some questions also in slides. You try to solve it by your own, and some questions are in your textbook. You can just try to your own. That is also useful for you. Some reference questions are also given in the last year question paper, which is already uploaded on the eLearn portal. Mr. Manoj, please check. It is available and everyone is getting it. Thank you so much.